Hey, everybody. Okay, first off, I strongly encourage you to listen to the intro to the video. Yes, I'm going to be going to the computer in a couple of minutes, and I'll show you the code, which is what everyone wants to see. But do me a favor, do yourself a favor, and listen to the intro to the video here about how we got to the code, okay? All right. If you're in competitive robotics, one of the hardest parts is programming your autonomous. It takes up tons of time to do well. So let's say you were controlling that bot and you wanted to, let's say you figured out a shortcut and say, okay, well, we're going to take a tape measure and we're going to measure and okay, we need to move forward 4 inches, 5 inches, a foot, whatever it is. Then we need a 45-degree turn. Then we need to move forward again, backward again. We need to use our intake or flipper or a lift or whatever it is. Well, what if you could drive the bot like normal and capture data and then essentially play that data back? That would be ideal. Okay? Well, that's what we're going to show you here. Okay, but you need to let's work the problem in reverse. Okay? A robot does not drive like you drive. When you go forward, you take 2 sticks and you push them forward. Okay, well, you may push the left stick forward a little more than the right stick, and then the right stick a little bit more than the left stick. And that's how a human drives. That's not how your bot drives. If you tell your bot to go straight forward, it's going to turn on left motors and right motors essentially at the same time. It's going to stop left wheels and right wheels at the same time. So we need to capture data in the manner in which your robot is going to play it back. So what we're going to do, we're going to go to the code in just a minute, I promise. You don't need, when you're capturing data for autonomous, you don't need to capture data using the joysticks. We need to write a short piece of code that'll let you capture data and control the robot using buttons. You've got plenty of buttons. I promise you'll have enough to move the robot forward, backward, do left turns, right turns, flippers, intakes, whatever you want to do, okay? That allows you, if you control the robot with a single button press, you mash the button, it's going to turn on all 4 motors, all at the same time, all at the same amount. It's going to be perfect. It's going to capture data and move the robot just like autonomous is going to play it back. And that's what's critical here. That's what we want. Now, just for the record, some people have written some stuff that'll let you actually drive the bot using the controls, capture the data to an SD card, pull it out of the robot, put it in programming, and okay, that's beyond the scope of this video, okay? All right, let's go look at what the team has written over here. All right. Pretty short little program. Let's start over here. When started. That's initial conditions, left up, left down to the left motors, right are the right wheel motors, and they have an intake on here. This code's a little old. I think they've got some flippers now, some outriggers. But anyway, this is good enough. Okay. And what they're doing here, in a forever loop, they're printing the motor degrees. Okay, we've got left motors, right motors, and the intake motor. Okay? We'll come back to that block in a minute. Let's move over here to driver control. Okay, here we go. When they press the up button on the controller, it turns on left motors, right motors at 30% speed. That you can obviously change that speed to your liking. We have found that anything much above 30 or 40%, 50% is going to make the robot wobble and wiggle, and you're not going to get good data, so you're not going to get repeatable results, and that's all what autonomous is about. Anyway, you mash this button, it moves the robot forward. So you start off, you mash the button, the robot moves forward. You come over here, you read these degrees. All the motors are usually going to be real close to one another. You can take them and average them if you like, do whatever you like. Then we're going to move down here to this section. You've written those degrees down on a sheet of paper. You're going to mash a button. They're using controller Y. And it's going to clear the brain rows and reset all of these motor degree readings, okay? This was a forward move. That's it in a nutshell. We'll go through the rest of it, but there is a reverse move. Controller down, moves backward 30% speed. This moves the left wheels in reverse, the right wheels forward. This is a turn. This is what is this? This is a right turn. The other one was a left turn. Here's where you control the intake, and there's where everything stops. So you drive your robot one stage at a time. You read the data. You reset the data, you write it down on a sheet of paper. And the really nice thing about this, in addition to everything you've seen already, sorry, I'm having trouble with my camera, is let's say you move forward with the robot and you say, oh, I went too far. Instead of having to start over, you just back it up a little bit. And those degrees that we're counting up, moving forward, they're going to count reverse. So you'll be able to get a valid reading, correct your autonomous, you'll be able to get a valid reading and continue on programming your autonomous. Saves it a lot of time. If you build a good bot that is reliable and doesn't work, it's not messed up and it's repeatable, it's consistent. If you do that, and if you'll plan out and test it manually ahead of time, the path you want to take, obstacles to avoid, don't get too close to the walls, stuff like that. If you'll do that, do this method, capture the data, write it down, come back, put it in code, 1 step, 2 step, 3 step, 4 step, so on and so forth. This will get you about 95% of the way to a completed autonomous run on the very first pass. Obviously, there's going to be some fine-tuning involved. Usually the team has to deal with the turns. Sometimes the turns have to be sped up, slowed down, so on and so forth. But this is going to get you really, really, really close, really, really, really quickly. And I think that's about all I've got to say. It's pretty straightforward. When you think about it, it's a pretty obvious way to do things. It's not particularly groundbreaking code or anything like that. But if comments or questions, post them down below, and we will see you at Worlds.